Okay, now let's do this example here. So again, we've got this inequality here. We want to move everything over to one side of the inequality so that we get something with 0 on one side. So let's subtract off this from both sides. So if I do that, then I get what? I get 1 over x minus 2 minus 1 over x plus 3. Okay? And so that's what I get on this side, because I'm just subtracting this from both sides. So I get this, and of course this will give me 0, and so I get that. So now I'm going to make this into one large rational expression, so I'm going to get a common denominator. So I've got x minus 2 here and x plus 3 here, so I'm going to multiply this side by x plus 3 over x plus 3, and then over here I'm going to multiply by x minus 2 over x minus 2, right? So what's going to happen? In this case here, I'm going to get x plus 3 over x plus 3 times x minus 2 minus x minus 2 over x plus 3 times x minus 2 greater than or equal to 0. So now I can combine them into one fraction. So, and again, pay attention to the subtraction here, because we're going to subtract this whole thing. So it's going to be x plus 3 minus x minus 2 all over x plus 3 times x minus 2 greater than 0. So now if I go up here, what happens to the numerator? Well, if I simplify the numerator, right, so I'm going to distribute the minus. So if I distribute the minus, that's going to mean it's going to be minus x plus 2. So if I get x minus x, those drop out. And then 3 plus 2 gives me 5. So I'm going to end up with 5 all divided by x plus 3 over x minus 2 greater than or equal to 0. Now, for solutions, there are no real solutions because there's no value of x that will make this equal to 0. Okay? So there's no real solutions to this. Okay, so in other words, there's no intercepts either. So no zeros, right? So now what? Now we look at the bottom and say, okay, what are the values of x that give us undefined values? Well, that's going to be at x equals -3 and x equals 2. Those are going to give us places where we're going to have what? Vertical asymptotes. Okay? So now we've got -3, so I'm going to leave that up there for a moment. Okay. So if we're looking at our intervals, so let's do our intervals. So one interval is going to be it's going to go from -infinity to -3. And again, -3 and +2 are not going to be included in our solution set, since those are where vertical asymptotes are located. So then the next interval that we're going to test is going to be from -3 to 2. And then the next interval is going to be from 2 to +infinity. And so now we look at the sign. of the function. Okay. Well, if I put in -4 here, what happens here? This is always, the numerator is always going to be positive, right? So that's going to be positive. Here, if I put in -4, this is going to be negative. And if I put in -4 here, it's going to be negative. Well, a negative times a negative is positive, and then I'm going to get a positive divided by a positive, which means that this is going to be positive. Now, what if I put in 0? So 0 is always the one that we want to use. So 0 will give us what? Positive here and negative here. So then we get a negative on the bottom, positive on top, which means this is going to be negative. Now, what about here? So if I put in 3, I'm going to get positive, of course, positive, and this is going to be positive, which means the whole thing is going to be positive. So now, so solution set, again, greater than or equal to 0, but since we don't have any zeros or intercepts, we're not going to include, and we're not going to include 2 and -3 because those are where vertical asymptotes occur. So the solution set for this is going to be, well, it's greater than or equal to 0, so it's going to be what? It's going to be -infinity to -3 union 2 to positive infinity. Okay? And if we wanted to use set builder notation, it would be the set of all x such that x is less than -3 or x is greater than 2. All right, that's it.